So we are working through the questions in your notes about discriminates, and we now come to the last question, question 9, which asks us to show that this will always have real roots. Now we know that in order for something to have real roots, my discriminant is either going to have to be greater than 0, or it could be that my discriminant is equal to 0. These would be my two options if I have real roots. So let's begin by writing out what my discriminant is. It's b squared minus 4, minus 4ac. Let me then identify what my a, b, and c values are. It will be q, it will be 3, and finally it's going to be minus 6 minus 4q, minus 6 minus 4q. Next, I'm going to sub these values into my discriminant. So I'm going to get that my discriminant is going to be b squared, which will be 9 minus 4 times q. And then I'm going to times it by c, minus 6 minus 4q. Then I'm going to expand this out. So my discriminant is going to be equal to 9 minus positive, actually, 24q. Don't get mixed up with your negatives. And then negative 4 times negative 4q will be positive 16q squared. So I could finally write it, just rearranging it, bringing my q squared to the first term, then plus 24q, q plus 9. Then I would, let me just break this up for a second. And break it up over here. So I have identified this. Let me bring this over. My delta is 16q squared plus 24q plus 9. Don't get confused between my 9s and my q's. And hopefully what you now realize is that this could be written in a better way. The tip-off would be that I have something squared here and something squared here. The square root of 16 is 4, the square root of 9 is 3, 4 times 3 is 12, times 2 is 24, so this is in the form of a perfect square. So it's going to be 4q plus 3 squared. That is something that just comes with time and practice, being able to spot those perfect squares, but it's really essential for answering this question. So now we are in a position where we have this perfect square, and it's very important that we have this squared out the front, which means that there is actually no way that I could get a negative number, because even if I got a huge negative number within my brackets, I'm going to square it and it's going to become positive. I could have 0 inside my brackets, but if I had 0 inside my brackets, that's fine, because in order to have real roots, I could have 0. That's fine. So now, if you needed further proof that I'm always going to get a positive or 0 number out of this, I could graph it. My vertical axis would be my delta, and my horizontal axis would be my q, and my q-intercept would be negative 3 and 4, negative 3 and 4, and I could give this a quick graph. Let me do it in red. That's horrible. Let me try again. Not great, but as you can clearly see, everything is above my q-axis, and therefore I only produce positive delta values. And this demonstrates that my discriminant is greater than or equal to 0, and therefore I will always have real roots. Hopefully this explanation has been helpful to you, and if you do have any questions, please don't hesitate to come find me and ask.